Question 21. In the binomial expansion of a plus 2x to the power 6, where a is not 0, the coefficient of the term in x squared is equal to the coefficient of the term in x. Find the value of a. Now what's interesting here is they're not actually asking us to expand the whole thing, right? They're just comparing the coefficient of x squared to the coefficient of x. So I know then, when I do my Pascal's triangle down to this row here, where the second number is obviously 6, that's what I need. I actually only need to work out the first 3 terms here. I don't need the rest. You'll see why in a minute. But, you know, in terms of the general formula, a plus b to the power 6, well, it will be a to the power 6 to start with, won't it? A to the highest power. Plus then, well, the coefficient there is 6. A then to the power 5, because you reduce the a's, and it'll be b. Plus then the next coefficient, which is 15. A to the power 4, reduce the a's, increase the b's, b squared. Now I know we could stop there because in our substitution, okay, a just stays as a, doesn't it? The b becomes 2x, and I know if b becomes 2x, when I put it in there, squaring it, I'm going to get x squared, aren't I? I'm going to get x squared, which is what they're comparing here. They're comparing x squared to the x term. So I don't need to go any more, okay? So if I substitute a stays the same, so that's really easy. Okay, but b becomes 2x. And in this case, then you've got to square it. Okay, so take your time on this here. Now, with regards to this here, let's multiply the numbers. 6 times 2 is 12. And then let's just take our time on this. Square that, you get 4x squared. And the idea is to make sure, once you simplify this, make sure the x terms are at the end. So 15 times 4 then is 60. And you've got the x terms at the end, right? Now let's look at what it says then. So it says the coefficient of the term in x squared is equal to the coefficient of the term in x. Now when we talk about coefficient, we're talking about the stuff in front of the x terms, right? Or the x squared terms. So the stuff in front. So they're saying actually these are equal. That's what it's saying. So coefficient of the term in x squared is equal to coefficient of the term in x. Okay, we can literally say that because that's what the question is stating, isn't it? That the coefficients are equal. So they're equal. I can set them equal like this. And then, okay, because a is not equal to 0, okay, it says in the question a is not 0, we can actually do some dividing here, okay? We're allowed to divide by a, for instance, because a cannot be 0, okay? If a was 0, we wouldn't be able to divide by it, wouldn't we? Okay, because we're not allowed to divide by 0. And also, if a was 0, it would sort of, this wouldn't be a binomial then, wouldn't it? It wouldn't be 2 terms, it would just be a single term. So we're going to do dividing. And the reason why I say dividing is because if you notice here, we're timesing these terms. It's 60 times a to the 4, 12 times a to the 5. So what I'm going to do, because they're timesing, I'm going to sort of take them over the other side and divide. So what I mean by that is, if I got 12 times a to this 5, I'm going to take the 12 over and divide. Because you're timesing here, when I take it over, of course, I've got to do the opposite and divide, yeah? And because I'm timesing, as I said here, I'll keep the a to the 5 where it is now. I've taken the 12 over. Because I'm timesing here, I'll take the a to the 4 over. Okay? And then you'll see then, well, 60 divided by 12 is 5. a to the power 5 divided by a to the power 4. Well, you just use indices. Take the powers away, and you get your answer straight away.